today, and let me share here for a second. I am Cheryl Wilson-Griffin, and I am the CEO of Legal Tech Consultants, and you are joining us for a live recording of AI for Smart People. This week, we're going to be talking about a new topic that we haven't really touched on, which is really taking a look at how we buy and what we buy from more of a product development perspective. And I have with me today a guest that I've known a long time, and I've worked with them previously. So Paul is from Yonder. He's the head of innovation at Yonder, which is a product development company. And I actually got the chance to meet Paul several years ago and get to travel to Romania to see him. Several years ago when I was working with him on a product that I was working for. And we've been kind of keeping up, and Paul had talked to me a little bit about some research he was doing in the product space, really focused on, giving good advice to the clients that Yonder's working with. And as we met and talked a little bit about it, I thought, wow, this could be very useful information in the legal space where maybe we don't always think about the technical implications of product decisions and how they either impact our buying, what we expect from them, and also kind of the outcomes that we get from them. And so that's the goal today. We're going to leverage Paul's insights and research from a product development perspective, and we're going to develop and mature our approach to evaluating and buying AI solutions. So that is the game plan today, and I'm very excited to jump right in. Just a reminder for everyone, we do record this once a month, so we have different guests every month. Next month will be, let me share my screen here. Our next guest next month will be Jill Bomarito from 273 Ventures. You may know 273 Ventures. They recently released a large legal language model, I think is what they're calling it, called Kelvin. And so she'll be on next month to talk to us about compliance and risk, which sounds like not a sexy topic, but she and I had a really fun time prepping for it. So I think that's going to be a cool session as well. So with that, Paul, I thought I'd stop and let you do a proper introduction to yourself, and then we'll jump right in.
Yep. Thank you for having me, first of all. It's great to be here and have the opportunity to share some of my knowledge in terms of software products and AI. Indeed, I still remember, Cheryl, when we first met in Romania. I was immediately pleasantly surprised by your energy and how contagious it is. I'm joining today from Romania. It's quite late in the day, so sorry for my slow pickup on energy. But usually having conversations with Cheryl, it's quite hard to stay low on energy when we're having discussions. So yeah, it's great to be here. Mainly, I'm going to try to leverage my expertise, as I said, in software development and AI. First, I started to look at AI more closely in 2017. That's when I first had the opportunity to train a neural network. And ever since then, I've closely followed, I stayed close to this space and did different experiments with different customers. And especially in the last 2 years, it feels like the field really took off. And nowadays, just keeping up with new things that come up is like a second full-time job. And I think it's quite important for professionals to have a good understanding, sort of to be able to look beyond the hype and the mist, the smoke and mirrors that we see in this space. And hopefully during today's discussion, we can bring some structure regarding how to make certain decisions when it comes to AI-related products. And together with Cheryl, hopefully we can provide some insightful content on this. So thank you again for having me here, and looking forward to a good discussion.
Me too. Well, let's jump right in, and I'm going to pull up one of my favorite slides that you use to start with, which is really, thinking about the different mindsets around AI, right? We've had a little bit of people saying the world was going to end, people saying it's going to be the greatest thing since sliced bread. Talk us through this slide, because I think it's such a great representation of where we're at.
Yeah, this image really pops into my mind whenever I think of AI, especially in the last 2 years. And if you look closely at this picture, you notice there are three different perspectives around the AI hype train. So in this case, we have the dad, which is overly enthusiastic, thinking AI is going to change the world. And I'm sure that if you work in companies, if you have colleagues, maybe yourself, there is this tendency to become overly optimistic about this technology. I think we as humans, we've always been fascinated by this idea of having computers that mimic human intelligence. And there is definitely the happy campers, the ones that are going for, hey, AI is going to change everything. 6 months from now, like jobs are not going to be needed anymore, and we're going to have universal basic income. Then there are like the mom in this picture. We have those which are a bit more cautious, a bit more reluctant, and putting more the spotlight on the risks, the challenges, maybe the threats associated to this technology. And I'm sure either yourself or you have someone around you which whenever you say something about AI, they tend to come up with this long list of risks and incidents. But did you hear that it did that? And do you know that it hallucinates? And do you know that it's vulnerable? And so on. And then there is a third category as well. In this case, the baby in the picture, this is the group of people which are genuinely confused about what's going on. So on one side, they see the overly enthusiastic people, they see the scared people, but because they haven't took the time to kind of look at what's going on, they're in this middle state of, hey, I have no idea what's going on. It's not clear. Is this just hype? Is there any value behind it? And usually those are the people which are kind of staying away from the conversation and trying to avoid it. And I think the pragmatic approach is to try to bridge these three perspectives. I think each of them have a good position to justify, but I think the truth or the pragmatic approach lies somewhere in the middle. And I think when we look at this technology, and not AI, but new technologies in general, a bit of optimism combined with a bit of skepticism, and also in some cases just knowing when to stay on the sidelines because it might be too early. I think that's quite a good perspective and quite a good approach. So yeah, that's how I approach it. And even though I started as an enthusiast, then I also started to put the focus on risks, and now I'm somewhere in the middle.
I love that. And I think too, you've hit on kind of the law firm leadership perspective, I would say as well. We've seen this in legal already, right? We've seen the firms that went out and bought Harvey on day one. It was like the announcement came out, they bought Harvey, right? These guys, this is the dad. We've seen people who are blocking ChatGPT and blocking everything wholly. That's the mom. But I think most of the people I talk to are somewhere in the middle and are the baby and a little bit confused. And I don't think it's for lack of interest or anything like that. A lot of times it's just, what's the right information, right? There's so much crazy information out there. It's what's the right information. So as we think about that, let's talk a little bit about the hype cycle and just check in with the hype cycle and see where you think we're at on this kind of on the curve.
Yeah. I think the slide kind of it gives it away immediately due to the headline last year. Then the word AI was named the word of the year, which definitely, in my view, sounds quite ridiculous, but it's a clear indicator that right now we're quite high on the peak of inflated expectations. In case someone in the audience is not familiar with the hype cycle, it's basically looking at how consumer expectations evolve over time. There are 5 stages. First, there is a new innovation or a new technique that is created. People start to hear about it, and slowly they start to get more excited about it. Then when we reach at the peak of inflated expectations, we have a lot of happy campers over, hey, this is going to change the world. And then in most cases, people realize, well, maybe it's not as great as we thought. And that usually takes the technology through the throw of disillusionment. And then there is sort of a crossroad. Either the technology dies, or it slowly picks up again, going into slope of enlightenment and plateau of productivity. And I think what's interesting about AI specifically is that it has been through a couple of these hype cycles all the way back from the 1950s. If you read on the history of AI, you will find out that we've been through this cycle at least 4 times. So a new technique in AI comes up. People think this is going to change everything. It's going to take our jobs. Then we realize, well, maybe it's not as great. And then that technique usually reaches a plateau of productivity. And then a couple of years later, something new comes up. And right now, I would say the new kid on the block when it comes to AI is generative AI and large language models. From 2017, 2018, when Google came up with a famous paper called Attention is All You Need, that described one of the core architectures that power large language models. Since then, in my view, we've been slowly riding and getting on a new AI hype cycle. And funny story regarding this, I have a couple of friends of mine which are older and wiser, and they're telling me that this is also how successful relationships evolve. So you meet each other, that's the innovation trigger. Then the honeymoon is the peak of inflated expectations. And then you realize, well, maybe it's not as great as the honeymoon. Maybe he's not cleaning the dishes. Maybe she's not doing that. And then there is a critical point in the relationship, which is the bottom of the throw of disillusionment. If relationships can survive that point, you're going to get, I'm being told, into quite a good place where, again, it's not honeymoon, but still it's a really good place in the relationship. And I think it's interesting whenever you hear about new technologies, new techniques, always to keep in mind this hype cycle and this image, and try to ask yourself, where is this technology, this new innovation seated on this cycle?
Yeah, and I think too, really interesting. I love the relationship thing. I don't know where I'm at. I'm not going to ask you either because I don't want a record of it. But thinking too about, right, I think even about home prices and home markets, right? When you think about buying, I bought a house at the top of like the last big housing market boom in the US, and I paid a premium as a result of that. And months later, the 2008 collapse happened, and the good news was I didn't need to move, so I wasn't stuck with anything. It didn't really impact me. But if you're buying technology at the top of this cycle, there's a lot of risk on the backside of the cycle. And so I think that's the first thing that I would think about is how realistic are the expectations to what's being promised? And that gives you a good gauge of where you're at. So you never want to buy at the top of any cycle, right? Buy low, sell high. That's the rule they say. But let's keep looking. Let's keep cooking so we have so many topics to cover. All right. So let's talk foundationally, because this is going to come up as we dig into some of our advice a little bit later, but just to make sure everybody's on the same page. Let's walk through kind of these kind of one by one. So thinking kind of about artificial intelligence as a concept, can you just give us a kind of brief overview and set the stage for that?
Yeah, so the term artificial intelligence really started to pick up in the 1950s. And it started by referring to pretty much any technique that allowed a computer, a machine, to mimic human behavior. Again, it could have been quite primitive systems that were not intelligent at all, but they were kind of fooling you. They were mimicking how humans make certain decisions or how they take certain actions. And actually, one of the first AI systems that was ever developed was in the 1950s. It was a system that was able to distinguish between pictures of males and females. And until that point, the traditional approach to this type of problems was to instruct the computer how to distinguish between males or females, or how to do pretty much anything. It was the way we were interacting with computers was quite imperative. But with this new type of technology, with artificial intelligence, this system started to learn by seeing data and by being exposed to data. And in general, there are three types of AI systems. First, there are artificial narrow intelligence systems. These are AI systems which are really good at one thing. One of the famous example is when you pick up your phone and you're trying to take a picture of a person, you might have noticed that your camera automatically puts a square around person's faces. That's actually done with an artificially narrow intelligence system. It's a system that is good at detecting faces in pictures. Then there is AGI, or artificial general intelligence systems. These, you might have heard in the news recently the term AGI. It refers to this super computer which is able to reason and to actually make intelligent reasoning and decisions. People think that we're quite close to AGI, but most pragmatic experts in the field still think that we're a couple of years away, maybe 5, 10, 15 years away from proper AGI systems. Some of the systems that we have nowadays, like ChatGPT and so on, you might have noticed that they struggle quite a bit when it comes to planning, when it comes to reasoning, and when it comes to like proper deep thinking or solving really difficult tasks. I think there are leads that will take us towards AGI, but still I think it's a couple of years away. And then there are artificial super intelligent systems. At the moment, this is pretty much science fiction. It refers to things like the Terminator, so machines which are able to be better than humans on all domains. Then a subset of AI, or artificial intelligence, from the 1980s is machine learning. And these are techniques that use statistical methods to enable computers to improve and get better with more data or with more experience. And there are three types, again, of machine learning systems, mainly three types. There are supervised machine learning systems. These are systems where you feed in your data and you're also giving the labels or the answers to your data to the computer. So an example of this, again, would be the system that is able to pick up your face in photos. The way Apple trained that system is by giving lots of pictures of humans to the computer, but also labeling or instructing the computer where is the face. And with enough data, the computer slowly starts to pick up the similarities, like what makes a face a face. And it picks up subtle details like the color, the shape, all these kind of things. And with millions and millions of images, which are labeled, again, are also given the answer to it, the system can pick this up.
Yeah, I think it's really interesting too. Even I remember someone telling me that some of the CAPTCHA, where it says select all the bridges in this picture, was actually part of image training, right?
Yeah.
That they were actually using us to train the model a little bit by saying, well, help us figure out what bridges are the characteristics are.
Yep.
So I think that's it's pretty neat to think about how far we've come. And then when we think about deep learning, that's where kind of all the fun stuff is happening, right? That is where the large language models are. That's where the generative AI stuff is. And that's also probably where the stuff that's most risky and dangerous is, right? It's the newest.
It's also because it's the newest, but also it's because in that space we're working with huge amounts of data, and predicting behavior and predicting things in complex and high volume systems is really difficult. And one of the main challenges that we have with generative AI solutions and with deep learning solutions is that often we don't know why they behave in a certain way. we don't really know why they make certain predictions or why they come up with certain things. And this is like an entire research field of scientists trying to kind of debug or reason back to why the model is giving a certain prediction or a certain output.
Yeah, I mean, I think too, one of the other things about kind of generative AI, and you and I talked a little bit about it. I did a post about it a while back, was my ChatGPT, when I talk to it, keeps wanting to insert the word meticulously into everything I do. And it turns out after I did a post about it, that everyone's ChatGPT has some word that it's hooked on, and it's not my word. It's different for every single person. And so, I think when the fact that we don't know, right, sometimes what exactly is happening or what the outcome is going to be, I think really behooves us to talk to each other about what we're doing. I think that's another way as you're learning to think about, I didn't have any idea that that was a thing. I thought I had programmed it like, I don't know, I thought I broke it or something. And the idea was really, oh, it's probably something that I accidentally inserted in there earlier. And everyone has done that, right? We all have tendencies. So I think that's really one of the fun parts about, I think, generative AI is just that we are not totally sure what the outputs are supposed to be.
Yeah, fun thing regarding that, there is actually a top 10 most common ChatGPT words. And one of them is actually delve, like you're diving into something.
Mhm.
And someone did a research on all the recently released scientific papers, and they've seen a spike in the word delve since 2013 like crazy, which is clear proof that people are writing scientific papers with ChatGPT like crazy. Uh, and there are actually techniques to, like, you can have a list of a blacklist of words to make sure that your text doesn't sound AI generated.
I love that. All right, that's for another session. But yes, I think I read the same paper and I thought, okay, well, all these scientists are not doing their own work anymore. So I love it. All right, so let's talk a little bit about really the how a product learns, because that is super relevant to how we select products. And so just kind of walking through the three different kind of ways products or systems learn. Can we talk through that, kind of starting with supervised?
Yep. So supervised, again, it's systems which you have to provide both your data and your labels to the system. And the example of apps or your phone being able to pick up faces is a good example of that. Google Photos, it's that you had here. It's also a good example for that. Uh, Basically, again, these systems are trained on huge amounts of data that are also labeled. And the main challenge with building these systems is having enough data, but also there is a huge amount of effort going into labeling it. For example, at Yonder, we've trained a supervised learning system, which can detect products in supermarkets. And it was a lot of the investment done into that project went into actually labeling the data set. So we would have humans going in supermarkets and taking pictures of like all the shelves. Then we would have a system that automatically crops the products, but then a human would actually have to sit and say, this is a beer of type A, this is a cereal box, this is this and this. That effort is needed in order to prepare the training set for these systems. And yeah, one of the main risks that come with this is that you can easily introduce biases into the systems. So depending on your data set, you can easily either have, for example, in our case, we had certain products being reflected by the light in the supermarket in a certain way. And because of that, the system would think that for a product to be a product, it needed to have a certain reflection on it. Or there are common mistakes with labeling, because again, this is a process done by humans. And these are some of the common vulnerabilities associated with supervised learning. But I'm curious to hear about Kira. I haven't heard about that.
Yeah. So Kira Systems is a product I think a lot of folks on the call will be familiar with. It was a contract review system that really used some early AI. I think maybe it came out in 2015 or 2017, something like that. And the idea was you had to give it a training set of your contracts ahead to get started. So you had to give it some training data, help it figure that out, and then you could move forward. And so that's, I think, when you think about supervised learning, anytime that you have to give it training data before you can start using a product, that's supervised learning. And I think that's a good way to put it, to think about it. The example I always like using for anyone who's seen it is there was a show called on HBO called Silicon Valley, and it was a series about startups. And one of the products they created was a product called Hot Dog, Not Hot Dog. And it only did one thing. It determined whether a photo was a hot dog or not. And the way they did it was just to give it a whole bunch of photos of hot dogs of different styles and say, these are hot dogs. And then they gave it pictures of cats and said, these aren't hot dogs, these aren't hot dogs. And so that was the whole kind of product, which is hilarious to think about. But it's a good way to remember what supervised training is, and that will make a big difference to you later when you're selecting technologies. All right, so let's talk next one, unsupervised. Let's chat through that one.
Yeah, so this is basically taking huge amounts of data and throw it at the computer and let the computer find similarities, anomalies. Kind of it tends to cluster information. Unsupervised learning systems are great for clustering things. An example is you can take data about customers. Let's say you have customer profiles with their name, their age, their buying preferences, whatever. Like Google has a profile like this for each of us. That's how they use targeted ads. And Google actually uses unsupervised learning quite heavily in order to cluster ad customers or potential buyers into different buckets. And the system, again, this is great for when you have huge amounts of data, because if you have like small data sets, it won't be statistically significant, the outputs that you get out of these systems. This really works when you have huge amounts of data, and it's virtually impossible for a human or for a classical system to classify or to group or to cluster that information. Yeah, it's the way I look at it is when you want to group certain things or cluster certain things and you have huge amounts of data, or when you want to find certain similarities or patterns or anomalies, then you can use some of these systems.
Right. So this is great for things where you don't really know what you're going to find.
Exactly.
You might have a theory, but you don't actually know. And so one of the great examples, so fraud detection, of course, the banks use that and have used this for years to watch what we're spending money on, to figure out that if I show up in China on the same day that I'm in Atlanta, that's probably not me, and they cut the system off automatically. But it's learning from my patterns. And then in the e-discovery space, an example is BrainSpace. And so for those who aren't familiar with it, it's a discovery tool. You have this big production from discovery, lots and lots of data, as you said. You throw it in there and it starts to bring out topics and themes and kind of cluster things. And so that was one of the really early tools that was advanced in kind of the legal tech space around unsupervised learning. And it continues to be growing and getting better and fancier every day. All right, so the last one is reinforcement learning. So let's talk a little bit about that.
Yeah, this is quite fun. It's pretty much the technology that powers self-driving cars and systems that can play chess. And not sure if you heard about AlphaGo. It was the system developed by Google which defeated the Go champion, the Go grandmaster. I think it was a couple of years, 2017, around that time. It was the first time when a computer was able to defeat a Go grandmaster. And not sure if you're familiar with the game of Go, but you can think of chess, but way more complex in terms of number of possibilities and strategies. And again, a computer using reinforcement learning was able to defeat a human and even come up with certain strategies or plays that humans haven't thought of before. And the way reinforcement learning works is you define the rules of the game or the boundaries of the environment, and you define a reward. You say, this is what success means. This is how you win, and these are the rules, that the moves that you have available at your disposal. And the system basically experiments. It basically tries to get to that reward billions of times. Like literally, you have a system that simulates that game, and from each experiment, it tries to learn something. One of the common beginner examples of reinforcement learning systems is, you can think of mazes. Not sure, so most likely you've done a maze with like a pen and paper, where you have to go with your pen through that. You can actually use reinforcement learning. You define the maze, the boundaries, and you say you have to get to this point. And then the computer will start drawing lines initially randomly. First, it will go to a corner, then it will get stuck, it will go back, it will get stuck again. But after millions or sometimes billions of attempts, it will kind of pick up the pattern. It will kind of pick up that, hey, I need to go left after I go 2 times right. And again, self-driving cars, what Tesla is using, are built also on reinforcement learning systems. This is how I sort of think of it.
I love it. Yeah, I think too, when you think about reinforcement learning, I think this is where people start to get a little nervous, because it does seem like it's thinking for itself, but it's really experimenting in the background. We're just not seeing that.
Yeah.
Excellent. Okay, cool. Great. Well, let's now then turn. So we've talked kind of about the different training ways things can be trained. We've talked a little bit about the different models, but now let's talk a little bit about the different models. And so kind of there's really 2 types of models to be thinking about as you're selecting products. There's really these base models and these pre-trained or these fine-tuned models. Can you walk us through kind of the difference between those?
Yeah, but maybe before I jump into that, it's worth looking at why this is important, or why would you care what type of model is being used. And I think the main reason for that is that in the last 2 years, in my view, AI has kind of become a badge of honor, a sticker that is being thrown on pretty much any product to try to sell it better or to make it more appealing. And often that entire badge of honor, it's pretty much a facade. It's something like the investment that the company did in order to get that badge of honor was quite small. It's like putting something together and saying, hey, now we have AI. And I think that's why it's important to understand the model, the model that the product is selling you, because that will be an indicator of the investment that company has made into their AI capabilities. And as Cheryl said, really you can mostly 2 types of AI models. There are the base models or the pre-trained models. Some companies call these also the foundational models. And these are models that have been trained by companies on huge amounts of data. I would say 80% of that data coming from the public web. So these companies like OpenAI, like Mistral from Europe, like Anthropic, are pretty much crawling the web and trying to get their hands on any type of digital content that they can. So whether it's papers, videos, books, and so on. They take all of that data, they train a system, and that becomes a base model or a pre-trained model, or you can think of it as a general model, like a generalist doctor. It knows pretty much of everything. It can write poems, it can tell jokes, it knows programming, it knows how to give dating advice. It knows a bit of everything. It's like a big soup. And again, these models are quite useful. ChatGPT is such a model. But there are also the fine-tuned models. These are models that start from a base model. So let's say a company that is providing software for the legal industry takes a base model, one of these models that has been trained to be generalists, and using proprietary data or using domain-specific data, they retrain the base model to make it more specialized for one thing. Obviously, this process requires way more effort and investment than just using a base model. Using a base model, you just interact with a service and you send your data to that, and then you get back the answers. But fine-tuning a model requires quite a bit more thought and investment. And what's great about fine-tuned models is that they perform way better at specialized tasks. And also, one of the challenges with fine-tuned models, especially fine-tuned large language models like ChatGPT, is that in order to properly fine-tune such a model, you really need huge amount of specialized data. Because you can think of these large language models like the water in an ocean, and fine-tuning is bringing your own buckets of water and mixing them with an ocean. Now, even if your data, even if you have like red paint and you dump it into an ocean, it's not going to make a difference. That's why in order to fine-tune models, you really need like big trucks of data that you dump into like a lake or an ocean in order for them to make a difference and to be able to actually steer the model towards a certain direction.
Yeah,
So, yeah.
Oh, well, I was going to say an example would be Harvey, right? Harvey AI, that's probably the big one in legal right now. And when we really don't have a ton in legal right now, and part of that reason is, right, we don't have a lot of great public data that we can use, right? People have their individual data, their private confidential data, but we don't have that huge data set that is widely available to kind of train across all those things. So in legal, we're largely working with the base models in most cases these days.
One interesting trend regarding this is synthetic data. So indeed, people realize that we don't have enough proprietary data, but you can actually use AI to generate training data. So this is kind of a big trend now. It's still early research, but I think it will kind of become a trend. So even though people have just a bucket of red color, they will generate more red paint with AI in order to make enough data to be able to fine-tune a model. But right now, as you said, indeed, I think I've also read about Harvey. They fine-tuned, I think initially GPT 3.5,
Right.
and they were able to build a system which, according to their reports, was preferred by 97% of the lawyers that tested it. They haven't actually came up with like metrics on accuracy and things like that, but it is meaningfully better than the base model.
Right, and getting back to the idea specifically for legal, right? If you take it out and use it for accounting, probably not going to be so great, right? That's really, we're talking about focus there.
Yeah.
All right, so let's talk. So, okay, we got one more topic and then we get into all the recommendations and kind of thinking about the tips in more depth. So when we think about buying tools, it's not only that there is or is not AI being used in the product, but there's really the question of where it's integrated and how it's integrated. And that really in the end drives values and outcomes for you. And so knowing that the two main ways that AI technology can be integrated into a product can be very helpful in deciding whether or not it's actually going to meet the needs and your expectations. So let's start with talking about kind of the idea of add-ons, because that's what we're seeing a lot more of right now because it's quicker, it's faster, it's a little less expensive. Can you talk us through how add-on integration works?
Yeah. So really, I think this has become quite popular because we have all of these traditional systems that have been built for the last 10, 15 years. And suddenly a new technology comes up. And again, we're really talking about the last 2, 3 years. And people are starting to think of, okay, how can we, as soon as possible, start to generate value using this new technology? And obviously, for most companies, especially established companies, it's not really feasible to rewrite your software product to try to have a vertical AI integration into that product. So in most cases, for most companies, the pragmatic approach is to have like an add-on integration where you might have your core product or your core system, and you bolt on a small AI tool or an AI integration on top of it. And obviously, the advantage of this is that you can easily plug it in and plug it out. It's quite easily detachable. You don't expose your core system to that. If something goes wrong, you immediately cut it off. And also, if the technology from the add-on, like if the AI system that you're using becomes deprecated, like if there is going to be ChatGPT 20, which is fundamentally better, it will be easier to replace that AI brain into an add-on integration rather than a vertical integration. Now, I think it's interesting from a buyer's point of view when someone is pitching you an AI-based solution to try to get a sense of, hey, how is this AI model integrated into your product? And also you might think, okay, how do we integrate this AI offering into our own systems as well? So yeah, the main advantage is that you can easily plug it in, plug it out. The disadvantages is that often it will be isolated from your core product. This means that it can limit its ability to do self-learning and to automatically improve with time. It can do that, but it won't be as natural, and it will require kind of stretching around in weird ways. But yeah, I think add-on integrations are great for initial experiments, for trying to validate the value. But what we're seeing is that the more the companies get more into like leveraging AI solutions, the more they also start to look at vertical integrations especially if they're convinced that this is going to be a long-term solution.
Yeah, I mean, and I think where we see that, where I've seen a lot of it so far is back in the e-discovery space, is there's a ton of add-on products that are adding on functionality to Relativity right now, right? AI functionality. Relativity is a huge product. They have tons of your data. They're not going to just rebuild their system tomorrow. Sure, certainly one day they'll refactor, but they're not going to do it tomorrow to take advantage of this technology. They're going to just add it on in certain specific areas and will have certain functions. I think from a buyer's perspective too, and if you're tasked with adoption, one of the pieces of advice I've been giving clients is to really think about using add-ons as your way to start to kind of learn the technology, figure out the use cases, figure out how it works. And there's really two reasons to that. One is you probably already own the product, right? So it's already been approved by security. It's already through. You might just have one more checkbox to get through to get that in. You can often turn it on and off because it is modular. So a lot of the companies will let you say, oh, I don't want to enable this, or I do want to enable this. So you have some flexibility and control there. And then I think from an adoption standpoint, your users already know the software, or the core software. And so the idea of getting them to leverage an AI feature is so minuscule of a change, often that can make it more successful. So there's lots of great reasons to look at these products that are in the add-on space. But the more robust use of AI is really in things that are integrated vertically. And can you talk a little bit about that?
Yeah, so this is really taking an AI model and deeply integrating it into all the layers of the solutions. going from the data layer to the business logic of the solutions, and even in some cases the interface layer. And obviously, this is quite hard to do for existing solutions. It's way easier for startups or for new initiatives, new products to have this approach. And the main advantage is, again, this full integration, this ability to do continuous learning, to interact with all to have a deep knowledge of your data, of your processes, of how you use the product, and to try to use all of that to provide more value. Again, I think we're still early on. I don't think we have really, it's hard to think of enough products, mature products, which have vertically integrated AI in them. Like, even if you think of the big companies, what Microsoft is doing with Copilot and so on, they're also add-on integrations. Like, they haven't rethought their products for the AI changes. Rather, they took Outlook or OneDrive, works exactly as before, and then they bolted on this AI capability. And again, I think that's totally fine. But I think slowly, as the technology matures and the market matures, I think we are going to start to see a new breed of vertically integrated products. And it will be obvious from the outside when you're looking at a vertically integrated product and an add-on, both from the value that it delivers, but also in some cases from how it looks, from how you interact with it, yeah.
Exactly right. Yeah, there's visual kind of cues. And I think too, thinking about the legal space specifically, the two that come to mind that I think that are out, although to your point, not mature yet, are in e-discovery. So there's a product called Ultimatum, there's a product called Beagle. Those products were built for discovery 100% with AI in every element of it. And so, so those can be great products, but we haven't seen, they're not mature yet, they're new. And so that is one of the reasons I suggest kind of starting with those add-on products that you're already comfortable with. And where you have something that maybe you have a big risk or a big spend, or you want to make a big change, maybe that's where you look for a vertical integration product. So if you're doing gazillions of dollars of discovery every year and you're hiring lots of contract reviewers and you're spending lots across the board, that might be the place that you want to look at vertical integration technology first, because it has the biggest gains to deliver to you. We did have a couple of, so we're going to have to jam through the last section, but we did have a couple of questions I wanted to throw out. One was, as a programmer, I find it hard to identify where AI can be used in the projects I work on. Any ideas how to approach an existing project and bring AI capabilities to it? And I'm giving you 2 minutes on that one.
Yes, I think as a programmer, the first interesting area to look at is using AI to program faster. So I would say there are two main things to look at. First, how can you use existing AI tools to make your work faster? And again, for programmers, things like GitHub Copilot and so on are great. And then how do you embed AI systems into the products that you work on? And really, my recommendation is to start by having a discussion with the product people that are responsible for that product, to try to understand what are the opportunities for problems to solve, what are the problems to be solved for our customers, and is there an opportunity to use generative AI to add more value to those customers? And yeah, I could talk like 10 minutes on this. You can start by looking at kind of the tasks that can be done with generative AI, and you can do a white spot analysis between those tasks that can be done by generative AI and problems to be solved at the customer. And if you find an intersection there, it means that there is something worth considering.
And I think too, if you are, one of the things that we've seen a lot of law firms and legal companies start to work to co-develop with companies. And I think, that kind of goes to the same thing, right? Look for those opportunities that are big and have a good application for AI and see where those line up. All right, so now we're going to get to the advice portion of the show. And so let's start talking about how we select a product. The first thing we want to look at is the type of AI model. Can we talk a little bit through that, kind of the idea of, base versus fine-tuned, right?
Yeah, so I think, again, I'm not that familiar in the legal tech space, but I'm guessing that most offerings that you're going to see out there are going to be base models. I think that what that means is that you need to be careful to what you pay for what you get. So you need to be aware that basically those companies are a thin layer over another company that actually trained those base models, whether it's OpenAI or Anthropic or whatever. And you should definitely not pay a premium on that AI integration unless they can prove that they are doing something meaningfully more valuable on top of just wrapping a base model. So that would be I don't know, the way we think of it. Again, it will be obvious and companies are going to clearly state if they have a fine-tuned model. They're going to say, we have our own model, is trained on our own data. And if that's the case, I think the interesting question is, will you also train your system on our data? How is my data playing a role into your trained model? And by the way, regarding base models, also something to consider, and this is more from a IT and security point of view, but a lot of these base models are actually offered as models as a service. So this is like software as a service. There are model as a service offerings where basically OpenAI or Anthropic offer their model via an API, via a service, which means that you're actually sending your data to their cloud. And one of the key questions, again, this is more from a security point of view, but one of the key questions, and this is true both for fine-tuned and for base models, but it will be more relevant for base models, is are we actually, when I use your AI, are we actually sending our data to a cloud which is not owned by your company? And again, that can be like if the company is promising that they give you access to GPT-4 or something like ChatGPT, most likely they will send your data to an external cloud. And that has certain implications from the security point of view that you should consider.
Yeah, I think there's a couple of big things there to think about, right? So one is the fact that when you have these base models and when that's kind of the underlying technology on a product that you're buying, if OpenAI or Anthropic introduces something new or makes a major change, that might break that tool. It might also render it completely valueless. There were some tools that came out after ChatGPT got released that did PDF summaries. ChatGPT or OpenAI released their own PDF summarizer, and all those tools were relegated to nothingness overnight. And so as you're buying those types of tools, right, which are pretty much all the tools we're buying or some base model, important not to get too committed to them, right? You don't want to go nuts integrating into them and doing a bunch of crazy stuff because they are probably going to change a lot and you have no control over it. The second thing, I think, getting to your point, Paul, around the security and privacy and that element is, yeah, I've worked with lots of product companies and helped them work through their privacy and compliance, and almost everyone who's using an OpenAI, that data is going to OpenAI at some point, right? And how long they keep it, I think, is another question to ask. So as you're buying, very, very big questions to ask. So let's think forward and kind of hit on that issue of training that you were talking about. And beyond kind of the, is it supervised, unsupervised reinforcement? There's also kind of how your data that you're putting in the system is being used. And we've seen a couple of different looks at that. Can you talk about kind of the different things to look for in that, how the product is trained element?
Yeah, so what I would, like most AI companies or AI features will market the fact that their system will get better with time, or the more you use it, the better it will get. And I think one of the key questions as a follow back to this is, can you show us a version of your system from 3 months or 6 months ago can we actually see the delta in improvement that actually took place? Because often, yes, the system is getting better with time, but is getting like 0.01% better in 1 year, or it's getting better, but not necessarily for your use case.
Right.
It might get better for other customers. So when someone is selling our system gets better with time, the reaction should be, can we see some proof of that, and can we validate that that will be meaningful for us? Because it sounds really nice, like continuous improvement, but I think there are a lot of smoke and mirrors behind that statement.
Yeah, especially right now, I think you're right. And as you're thinking about cost, right, you, again, going back to what you said, you don't want to pay a premium for something that's getting smarter if it's not really getting meaningful smarter for you. All right. So as we close out, let's look at some of the tips around evaluating and buying that we've come up with. And one of them is minimize long-term commitments. What's your advice there?
Yeah, just initially go for an add-on integration. Don't get yourself locked in into a long-term contract. Exactly what Cheryl mentioned, the tool that you're buying now might become obsolete in a matter of 6 months. And yeah, make sure that you approach it as an experiment rather than a long-term commitment buy.
Yeah, I mean, I'm sure the vendors are going to be asking us all to sign 3-year contracts. That's probably not a great plan right now. Let's talk a little bit about benchmarks and leveraging benchmarks, because there are starting to be some benchmarks here in the space. And one of them was Val's AI that you shared with me. But can we talk a little bit about how benchmarks can be helpful?
Yeah, I think that the main challenge is, how do we evaluate the performance of generative AI systems? And that's because generated content, like you can answer a question correctly in 5 different ways. And evaluating, putting a check mark on what's right and what's wrong, it's quite difficult to do in an automated way. And often these systems, they can hallucinate in a really misleading way or subtle way. And my recommendation is, if you're trying to buy a generative AI solution, make sure that you have a quiz of your own, a test set of your own, that it needs to pass before you buy. And again, it's really easy to be shown some flashy demos with certain test set data, but that won't necessarily translate directly to your own data or to your own use cases. So having your own test set, I think, is quite critical.
Yeah, and just as an example, that's not necessarily a new idea. You know, we did that in a firm, my last firm I worked in. We were considering Kira and Luminance against kind of human review for contracts. And so we already had the human review output. We knew what the results were. We knew how long it took them to do it. We could take that exact same set of data and put it in each of the other 2 products and then evaluate those results and make a selection. And so we're just talking about exactly that same thing here.
Yeah.
The other thing I wanted to just show people really quick, let me share my screen. Thinking about the benchmarks, and this is vals.ai, and they have a couple of different ones. But the idea here really is to think about how a particular model is going to work for your use case, right? So they've done one for, this is their legal bench, and it was last updated just a couple of days ago. But you can see they see Claude 3 Opus as the most accurate for legal uses, with ChatGPT not far behind. But this is something you can use to think about and match up the model that you're going to use with the use case that you're going to have. So I think that's a really cool tool, and it's got the people from Codex at Stanford and a couple of other people working on that project. Okay, last thing thinking about, and we're 1 minute after, so we'll wrap it up. You say watch what the big companies are doing, and let's talk about that, because sometimes the big companies aren't doing the most exciting stuff, but I think AI is one of those weird exceptions to the rule.
Yeah, it's mostly because they're in the best position to build these systems. It has to do with the huge amounts of data and computational costs needed to train these systems. And unless you're one of these big companies, as a small startup, it's virtually impossible to compete with the big guys. But also, I think what's interesting about generative AI in general is that you can apply general tools to vertical problems. like if you think of big tech before, they were mainly focusing on horizontal problems. So problems which were relevant for large amounts of people or companies. And they would never get into like legal problems or healthcare problems or like verticals, because it wouldn't have made sense commercially for them to target such a niched audience. But what's interesting about generative AI is that you can take a horizontal solution and start really easily apply it to vertical problems. And that's why I think generative AI is fundamentally different from traditional software and process automation that we've seen in the past. And that's why I think they're going to play a way bigger role in vertical markets like legal, and like a simple example, document management systems. Microsoft had that for some time, but now they're going to bring AI on top of OneDrive, and then they're going to allow you to do all kind of analysis. And with 3 vertical prompts, you can use that general horizontal AI to do things for your vertical. So I really encourage companies to look at the offering from Microsoft, from some of these big players, because I think they having the advantage of the economy of scale, they will be able to offer access to models and AI systems in sometimes 10 times cheaper than what a smaller company that is targeting just a vertical can do.
Yeah, it's a lot to balance because it's, you never want to get too deeply embedded with one company, but in this case, it's really where the cost savings are. So I think it's something to definitely consider as you're evaluating your technology stack. Well, Paul, thank you for being here today. The information you shared, I think, was really clear and really presented in a way that maybe we haven't heard before. And hopefully the listeners found this info helpful, and they're going to go out and buy technology and be smarter, wiser, faster, and impress everybody for the rest of the week. So thank you again, Paul. Thanks for everybody being here. Our next session will be May 7th with Jill Bomarito, and looking at compliance, risk, and all the less fun things of AI. And this session will be available in just a day or two on the Legal Tech Consultants website and on our YouTube channel, so definitely check it out.
Cool. Thank you.
Thank you, Paul.